4 here, guys. Questions number 10 and 11. Number 10 says a ball was thrown up into the air at a speed of 15 meters per second. Calculate the maximum height the ball will attain. This is, I like this question. I really like this question. This is a group B problem, right, that involves acceleration. Clearly, when they throw this ball up into the air, it's going to decelerate until the point where it does what? Yeah, it's going to stop, and then it's going to fall back down, right? So it decelerates, and then it stops, and then it accelerates. Now, it doesn't really matter whether we're analyzing the trip up or the trip down. The acceleration would be what? Negative 9.81 meters per second squared. Remember, you get a negative acceleration in 2 situations, where it slows down in the positive direction. So this ball is slowing down as it goes up. That's a negative 9.81. Or when it speeds up in the negative direction. So that would be, if we analyze the fall of the ball, that would be negative 9.81 as well, right? Now, we're only analyzing the trip up here. I'm going to write down that A is equal to negative 9.81 meters per second squared. And I'm going to write down that VI, the initial velocity of this, is 15.0 meters per second. Sorry, this should be meters per second squared. And the VI is 15.0 meters per second, the initial velocity here. What else do we have, guys, if we kind of read between the lines here for givens? Is there anything else? If I'm asking you what else do we have, and then I ask you, is there anything else? Probably is something else, right? Marcos? Would the final velocity be 0? Yes. If you're analyzing the trip up and down together, it wouldn't be 0. But if you're analyzing just the trip up, it's 0 because it starts at 15, it slows down, slows down, slows down. As it goes up, it slows down, slows down, slows down, and stops. And then it comes back down and speeds up, right? But we're not analyzing the whole thing, the up and down. We're only analyzing the trip up. So VF would be 0 for that portion of the trip. Now, what are we looking for here? The max height. I don't remember ever giving you guys an equation with h in it for height. So what is it that we're actually looking for here? Yeah, let's call it displacement, right? The displacement of the ball over the trip up would correspond to the max height, right? All right, so we got A, VI, VF, D, or we're looking for D at least. This is a group B problem. Which equation do you want to try? Which of those 5 do you want to try here? Pick. VF squared equals VI squared. VF squared is equal to VI squared plus 2 times delta D. That's what I would use too. That's a pretty common one to use actually, and unfortunately it's one of the harder ones to rearrange. Not the hardest, but one of the harder ones. Solving for delta D here, we got to get rid of what is not attached. What's not attached? VI squared. It's added on the right-hand side, so we're going to take it over by subtracting, right? VF squared minus VI squared equals 2AD. Still solving for delta D. Got to get rid of what is attached now. That's the 2 and the A. They're multiplied by delta D. Lucas, how am I going to take that over to the other side? The 2 and the A? Right. We're going to divide that, so it becomes VF squared minus VI squared. Careful, don't make it like this. Okay, we're not dividing something by 2A. We're dividing everything by 2A. Got that? Equals delta D. All right, so VF is 0. VI is 15. We did a problem similar to this with our practice quiz, right? With our fake quiz. 2 times negative 9.81. Let's go through this on our calculators. Make sure we can do this. Let's say 0 squared minus 15 squared. Let's press equals, get the number on the top, and then let's divide that by bracket 2 times neg 9.81. Good. Don't say, look at what I get if I do this. This is correct, right? 11.5 meters is correct. But look at what I get if I say negative 225 divided by 2 times neg 9.81. Like, shouldn't that be the same thing? but it isn't. Look at what I've done. Here I'm dividing 225 by 2 times 9.81. Here I'm dividing 225 by 2, and then timesing the whole thing by 9.81, not just the bottom by 9.81. That's why it's important to have the brackets. The alternative is you could actually calculate that first and then divide them to save yourself the brackets, but I like brackets. Good there? How many people got 11.5 for that? Or what is it? Yeah, 11.5? Good. If you didn't, does it make sense? Okay, let's take a look at number 11 now. Where's that? There you are. It says a rock is dropped from a height of 50 meters, high cliff. What's the velocity of the rock after 0.6 seconds? What's the displacement after 0.50 seconds? This is a perfect question to illustrate a neat little measuring technique. I remember years ago, this is quite a few years ago now, I was at a lake in BC called Maple Lake. You guys, anybody know where that is? Yes? My sister-in-law and brother-in-law have a place out there, and we went boating one day, and we decided, my nephew said, let's go cliff jumping, because there's this cliff that's pretty high that you can jump into the lake, and it's a really, really deep lake. It's like 100 meters or more deep, even right at the shore, so it's a perfect place to go cliff jumping. So we pull up to it in the boat, and then you have to kind of scale up this cliff. Sit in front of the boat, you're like thinking like, oh, this doesn't seem bad. This doesn't seem very high. And then we scale up the side of this cliff. It wasn't that hard to scale up. It wasn't like I'm a cliff climber, but it was. So I climb up it, and then I get to the top of it, and then I look down. And I'm like, ooh, this looks a lot higher than it did when I was standing, or than I was sitting in a boat over there. And I'm like, I said to my nephew, I said, who was about your age, how old you are now, I said, how high is this? He says, I don't know. And I'm like, ooh, looks pretty high. So I stood there for about 10 minutes actually, and I'm like, I don't think I can do this. And he's like, my nephew says, we don't really have a choice because there's not really any way down other than you can climb up, but you can't really climb down this cliff. So you pretty much have to jump. So eventually I did, and then I kept going time after time because it was fun, right? Like after you do it the first time, it's just scary the first time. But at one point we're like, I wonder how high it is. So we devised this simple little experiment to determine how high this is. We don't have a tape measure with us, right? But we got a watch. So what do? We took a rock, held it out, and we dropped it, and we timed it. Okay, let's say it took 0.50 seconds. All right, we know that the I is 0 when I drop it. My time is 0.5. My acceleration is neg 9.81. Let's find displacement. Make sense? Okay, a nice, easy way, a fairly accurate way as well to measure the height of this cliff. Now, we're doing these numbers these calculations in our head because we don't have a calculator, right? So when I'm doing this in my head, I'm not making A neg 9.81. What do you think I'm making A? 10, right? I'm making a negative 10. That's still pretty close, right? I don't remember what the height ended up being. It was high, but not as high as it looked when you're standing there at the top trying to get the courage to jump off the edge. Okay, so number 11 here. We're dropping this rock from a 50-meter high cliff. What's the velocity of the rock after 0.6 seconds? Let's write down our givens here. My time interval is 0.600 seconds for question A. I'm looking for the final velocity, the velocity after that time. Do I have anything else? If I read between the lines, do I know what VI is? 0. Good. Is there anything else that I have? Yes, I have acceleration is good. Negative 9.1 because this rock is falling. Do I know the displacement? Do I know the displacement? No. No, I do not know the displacement. Does it say this rock falls 50 meters? No. Just because the height of this cliff is 50 meters, it doesn't mean it's fallen 50 meters after 0.6 seconds. Does that make sense? We do not know the displacement here. If it said the rock fell and hit the water or hit the ground below, okay, D would be negative 50 meters, but we don't know that here, right? This is what I call blue car phenomenon. I can give you a question that says, a blue car is traveling at 10 meters per second for 30 seconds. How far has it traveled? Write down our givens. 10 meters, V is equal to 10 meters per second. T is 10 seconds. Color equals blue. Does the color of the car matter? No? Well, neither does that 50 meters matter, right? Sometimes data you're given just doesn't matter. Like the mass in that problem that we had. Looking for VF here. Looking for VF, the final velocity of the, yes, we already had that written down. Looking for VF, the final velocity of the rock. I'm probably going to try A is equal to delta V over delta T here. And then I'm going to say the T goes up by multiplying, becomes A times T. I got negative 9.81 times delta T is 0.60 seconds. And that gives us a value of 5.9 meters per second, 5.88. Negative 5.89, actually, meters per second. Does that make sense? You guys got that? How many people got that? Good. It is negative, right? I've actually solved for delta V. The change is negative 5. But if VI is 0 and delta V is negative 5, then what's VF? Same as the change, right? Same as delta. Now in question B, we're looking for the displacement after 0.5 seconds. So in question B, all the givens are the same except my time. And now we're looking for the displacement. You cannot use delta V there. You cannot use the same delta V you got from A. How come? 2 different times. Yeah, 2 different times. So your answer from A is not valid here. Why don't we try this? Why don't we try VIT plus 1/2 AT squared? VI is 0. 0 times time plus 1/2 of neg 9.81 times time squared, whoops, times 0.5 squared. Let's say 0 times 0.5 is 0, right? Don't need to put that on our calculator. 0.5 times neg 9.81 times 0.5 squared. Negative 1.23. Is that right? How far has it fallen in 1/2 a second? Negative 1.23. Oops, what's going on there? How many people got that one? Good, good. There are 2 more questions on this worksheet. Questions 12 and 13. 12 does a kilometer per hour thing. I'm going to refresh your memory on how to convert from kilometers per hour to meters per second. Okay, and then have you do number 12. And number 13 is a bit of a challenge question. Okay, 13, you see it says a car accelerates from rest for 4 seconds, and then it travels at a constant velocity for 15 seconds. I'm going to see if you can figure out what to do with that. Okay, in just a moment here. But the word then is important. Okay, it accelerates, and then it goes at a constant velocity. Not at the same time, right? it's accelerating, and then it's going at a constant velocity. So let's just really quickly refresh your memory on the kilometers per hour thing, and then we'll give you a couple minutes to do these last two questions here on this worksheet here. Remember, if I have, let's use a number of 36.0 kilometers per hour. I'm going to use that because that's an easy one for me to figure out in my head. 36 kilometers per hour. I want to convert that to meters per second. I got to convert kilometers to hours. What's the conversion? Sorry, kilometers to meters. What's the conversion factor for that, Nick? 1,000. Good. So we're going to times that by 1,000. And I also have to convert hours to seconds. What's the conversion factor there? 3,600, right? Because there's 60 seconds in a minute, and there's 60 minutes in an hour. So 60 times 60 is 3,600. So I'm multiplying the top by 1,000 to get meters, and I'm multiplying the bottom by 3,600 to get seconds. So in this case, I would end up with 36.0. Let's just say 36,000. Right, multiplying 36 by 1,000 on the top, and then 3,600 on the bottom, because there's 1 hour on the bottom. That gives me 10 meters per second. Make sense? Now, if you have to convert the other way around, from meters per second to kilometers per hour, which it looks like you do here, let's do it the other way around. 10 meters per second. Remember, I got to convert here meters to kilometers. How do you do that? Divide by 1,000. I got to convert seconds to hours. How do I do that? Divide by 3,600. If I'm converting kilometers to meters, it's multiplied by 1,000. Hours to seconds, multiplied by 3,600. If I'm going the other way around, I divide. So I'm going to say 10 divided by 1,000. Is that right? 10 divided by 1,000? Or was it 0.01? Yeah, it's 0.01, isn't it? 100. Yes, it would be 0.01. Yeah. Now I'm in kilometers on the top, and 1 divided by 3,600, I don't know what that is, gives me hours. If I go 0.1 divided by bracket 1 over 3,600, I get, 360. Oh, sorry, 0.01, yes. 0.01 divided by bracket 1 over 3,600 gives me 36. Make sense? So remember, in a question like this, you're converting two things, kilometers to meters, hours to seconds, or you're converting meters to kilometers, seconds to hours. And then you just do the math on your calculator. Okay, let's leave you with questions 12 and 13. 12 shouldn't be too bad except for these conversions. 13, you got to think about it a little bit differently. Let's see how many people can do that, all right? Let's get at it.